Alright, so let's go over these nomenclature questions now. So if we start with number 1, we can see we have two groups that are in a 1-3 or a meta relationship. And we recall that an aromatic ring with an NH2 on it is known as an aniline. So we can use that as our root name, aniline. And then this just becomes meta-methyl-aniline. Number 2 is very similar. We have the aromatic ring with an aldehyde for benzaldehyde. And then in a 1-4 or para relationship, we have an ethyl. So this becomes para-ethyl benzaldehyde. Now, number 3 brings us to a different situation, because in number 3, the aromatic ring is attached to a parent chain or a parent ring that has more carbons. So that means the aromatic ring here is the substituent and not the parent. Now, hopefully we recall from alkene nomenclature, we always number alkenes to give the alkene the priority over any substituents. So we number our 7-carbon ring in this way for cycloheptene. And then we just at carbon 3 need to name the aromatic ring as a substituent. So 3-phenyl cycloheptene. Notice I didn't put a number in for the cycloheptene. And that's because when the alkene is in a ring, if there's only one, because alkenes get priority, then we know by definition that alkene has to be on carbon 1. So while you could say 3-phenyl 1-cycloheptene, the 1 actually ends up being redundant there, and so in general we just don't put it in. Alright, number 4, if we use the hydroxy for its common name of phenol, then that means we have to define that as carbon 1. Once we've done that, it doesn't matter which way we number this one because the ring is symmetric. And it wouldn't matter if I went clockwise or counterclockwise. At carbons 3 and 5, we have the same substituent. So, as always, that means we put it in di. And the name for the NO2 group is nitro. So we have 3,5-dinitrophenol. So number 5, just to give you an idea, is about as complicated as we can get when it comes to aromatic nomenclature. And we're going to start it up here at the carboxylic acid, because we know that carboxylic acid group on benzene is benzoic acid. Which way do we number it? Well, going either direction, we're going to have the exact same set of numbers, 2, 3, 4, 5, 6. So what breaks the tie at that point is which direction has the first substituent alphabetically. And that's going to be over here to the left with chlorine. So we have 3-bromo, 2-chloro, 5-ethyl, and I'm going to run myself out of room here, 4-fluoro, 6-methoxy benzoic acid. Alright, for number 6, again, we're going to use the phenol as our root name based on the alcohol. And we can number it this way. So we have 2,4-dimethyl phenol. And finally, in number 7, very similar to number 5, we're going to have to number this based on alphabetical order. So of the 4 groups we have a pentyl up at the top, a tert-butyl next to it, and at the bottom we have an isopropyl and we have a chlorine. So of those, we know that tert-butyl, beginning with B, is going to come first alphabetically. And so that makes that carbon number 1. And then we go around to the right. So we have 1 tert-butyl, 4 chloro, 5 isopropyl, 2 pentyl, and unlike most of the other examples we did, in this case we actually didn't have any of those groups that could go into the parent name, so we just leave it at benzene.